Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
Okay, we're going to start again. And like I was saying, the following presentations is going to go really quick. Each one takes about 15 minutes. So I'm going to let each speaker introduce themselves and just go that quicker. Go ahead, Evelyn.
All right. Yeah, she didn't dare pronounce my name because I'm French, and so, you know, like just in case. So I am, thank you, Jan. So, Evelyn Viegas, can you hear me? Sorry?
We're not going to hold that against you.
Well, you know, I can switch to French right away, right? I mean, if you're that tough with me, so. So I work with Jan. I'm a colleague of Jan in the Microsoft Research Connections team, and I am the director of semantic computing at a very high level. It's looking at how we can make sense of data. At a detailed level, I really don't have time because I was given like 15 minutes. But having said that, what I'm going to do here, I think my goal is to have you go and try F#. And actually, not just that, I want you to go and try F#. My talk is done. Okay, so now, if I reach that goal, you know, we're gold here. So, sorry? You too, see? So actually, she put me here just to say that. So I'm going to talk about information-rich programming. So it may be slightly different from the talks you've heard earlier or in the other days, but I think everybody will come back to the theme here because I'm going to focus on the data part. So I think that's not controversial. We live in an information society. We can all agree with that. And if I put that into axioms, I would say, well, proposition 1, remember, I'm going to talk about, you know, some programming languages here, so let's have some fun. Proposition 1, the world is information rich, and I'm sure you would agree with that. Proposition 2, modern applications are information rich too, right? Like more and more, it's not, when we talk about data, there is more like, should I say, semantic information out there, right? And I'm sure in your field too. However, if we look at the programming, so here languages, I should say programming languages, because then I know that Crystal, who is at the end there, she will be talking about natural languages. So here by languages, I mean programming languages, they are information sparse. We don't bring all that richness of the information into those languages. So that means that there is a bit of a problem for the developer who now wants to develop applications where there is so much information, rich information out there. So what we're going to do, we're going to fix that with F#. Here I was told to do a plug on this book. I did not write it, just in case you were wondering. Actually, if some of you have read it and used it, you can teach me a thing or two here. But this is an F# book done for the data scientists. I browsed, it's really, really good, by the way. And the inventor of F# was on that one, too. So we want actually to fix this problem about bringing information into the language using something which is called type providers, and which is actually already today, I will speak, within the Visual Studio, So type providers, the way to look at them is language integrated data and services. But of course, some of you might say, well, but can you just tell us just a little bit about, you know, before you go to type provider, what's F#, right? So in just a few minutes, and why should I care? You care. I can just tell you that. I don't have time to die, but you do care. So in short, F# is a functional language. Practical, and I don't have time to get into all the details, which means that it's not purely functional. There is a little bit of other paradigms going on in there, but it enables you to write simple code to solve complex problems. Actually, so F# is open source. And not only that, what I want, when I mentioned at the beginning, I said I want you to learn about F#, and actually I want you to try F#. what we've done in Microsoft Research Connection, because remember, F# is a language which is developed, which is part of the Visual Studio Suite. But what we've done in Microsoft Research Connections, we have developed this try F#, which is, well, what if I don't have Visual Studio, right? What do I do? Can I still get a flavor, a sense of what this F# is? And that's exactly what we've done there. So let me see if I can. I should have a... OK, so what exists today, we have this site, which is where I would like you to try and go and try there, right? This is the Try F# website. And as it says here, we are providing tutorials, resources, and tools when you can start, even if you have never, ever programmed, you can start playing around. And there are, for people depending on your level, novice, expert, or just enthusiast, you can have different experiences. Even actually, right now, F# is targeting the developer, the researcher, the enthusiast. We are also here targeting the educator. So that's a site I would encourage you to go there just to find information, just try it out. So that's what we have today. So let me go back to what I started with, which is, well, OK, we have programming languages out there, but we also have a world where we have more and more information, richer and richer information, and we have not yet bridged the gaps between, on one side, the developer community, and on the other side, people who are producing this super rich data. And I said, well, one way to do that is going to bring in this new tool, which is, so to speak, which are those type providers. So the way to think about that is like, well, now we're going to design languages where we're going to bring this information out there into the language. And the solution, as I mentioned, are type providers. There are reasons why. So I didn't mention all the details about F#, but one we're very interested in are also like the type inferencing, because when we start talking about rich data, different types, so how can I use them, right, directly as I program? So to make it slightly more real, I'm going to go through a demo, which has been done for the World Bank here. And if you think of what this type provider is going to bring, is really what it says here is this intelligence for data. You know, when you type commands, actually think search too. You type a word, and now you start getting like some recommendations. Say, oh, you meant this or that. So now what this type provider, the idea behind the type providers, one of the main ideas is to bring this intelligence, not just for commands, but specifically for data. So we are going to bring in some types into as we program our applications. So let me give you an example. So here, this is a site of the World Bank. There are different data sets, and you could, right, go and look at the data by countries, by topics, data catalogs, microdata. So there are different categories. How can we do more in a much more interactive way? So let me now, so this is a screenshot of F# and the type provider in action. So let me go through that. So this one, can you see my cursor here? Yeah. So this one, we're going to look at the dataworldbank.org, which is this side there, which has all the data. And let me just go through the demo. And what we're going to do is like we want to access the data of this World Bank. Yeah. And now, because I have a type provider who knows about those types there in the data sets, so now I can, as I type, I say, well, you know, I'm interested in the countries. Well, actually, which countries am I interested in? And I can do that as I program. I'm bringing the data set, so to speak, into my programming environment as I type, right? So here in this case, I'm interested in Greece and actually the debt, which was very timely at the time of this demo being done. And then I can do typical things we can do when we program. I can sort things. I think we're going to sort. We're going to do this one here. We're going to sort some of the data, and later, and we will also be able to visualize as we go what's happening there, right? So that's really the idea. So the intelligence, so here's the visualization from 94 to whatever, 2010. this is what happened with the GDP of Greece. And now, well, I'm interested in other countries. So here I'm selecting Greece and Denmark. And all that comes because with my type provider, now I have access to those types. And this is one of the functionality of what you can do when you have a type provider. Okay? And here then you can visualize and show the different GDP of all those different countries. So that's what we mean by bringing into the language this rich information. Like now I'm bringing those types. I have all this data which is out there. And there are other things I'm not showing here, like on, which are really powerful too, like you can check on lat long and things like that. But I think I'm kind of running a bit out of time. So there was another demo. I will skip it. But again, try F#. And then you'll be able to see more. So what is interesting about F#, so this is not about, going back to programming and saying, going back to programming principle and saying, oh, we're going to mix languages and data. This is not what it is, right? You see, this is done via those type providers, and there is still, F# itself doesn't have data, right? There is still this separation. And actually, you can also write your own type provider when you go and find out about try F#. So some of the applications, so we already have some applications actually out there, some examples, but not on all of them. We have some on web data, the data markets, also with the Azure data market, there are some out there. Right now I'm working, I don't know if it's here, some semantic data. So we are trying like different type providers, and we will encourage the community to try yours, right? I mean, like if you want to look at, you were talking earlier, I was talking with you about, this neural network. Well, you have your graph, can you do something with it? So anyway, the idea is like you can try and build your own. So, and these are the properties, again, of the language. They're strongly typed, which is what we're interested in here. So, of course, if your data is not semantically rich, that would be an overkill, right? So here we're talking about data which is really semantically rich. So, in summary, the word is information rich. That means that, well, how can we bring it as we program? So we need to be information rich too. And I put the type providers at the rescue if you use F#. I recommend that you go back to this try F#. So by the way, right now on the tryf#.org, we still don't have the type provider there. They do exist. If you have a Visual Studio environment, you can actually try out the type providers. But if you don't, we are working on it. And so come back to this site, and you'll be able to find more information on those type providers within a few months. Also the blog, so Don Syme, and let me actually go and to this slide, because I really want to acknowledge, so Don Syme, who is actually, he did the forward he's basically the person who he's driving, the inventor of F#, and he's also working on the type providers. He's a principal researcher. And I also want to acknowledge Judith Bishop, who is the one who started this try F# project, working with Don Syme, which is like, well, what if you don't have a Visual Studio environment? I can try something, and then if I really like it, I can go and get the full experience, better functionality in the Visual Studio environment, right? And also Kenji Takeda, who is a colleague in the UK, who prepared some of those demos. And with that, I'm done, and I don't know if you have questions. Try F#.
Great. My name is Alex Wade. I am, what am I? I'm Director of Scholarly Communication within Microsoft Research. And how many people here are familiar with Microsoft Academic Search? How many people have seen it before? Okay, so 20% maybe. Excellent. Somebody said a couple of years ago in a slightly different context that trying to get semantic information out of PDFs was like trying to make a cow out of hamburger. And that's sort of how this project started. It started as an effort to take some unstructured data, to take PDFs that were found out on the web, and to try and recreate some semantics, recreate some structure out of that, really focusing on some general things that exist in research papers. First of all, identifying which of the PDFs that were out on the web were research articles, and then once we discovered that, made that decision, try to pull out the things like the authors, the author affiliations, the references, information out of that. And for a couple of years, this grew up around the computer science domain, and over the past year, we've sort of moved away from just finding research that's available out on the open web and have made a concerted effort to reach out to the publishers and try to start growing this up to all of the published literature. Right now, we've indexed about 38 million publications. We have a lot more publications in the queue. But really what this is trying to get beyond this idea of just having a simple search box that returns papers, and instead for us to create a graph of information that is about the relationships between the papers and the authors, the papers and the papers, the authors and the institutions, and then to be able to analyze that data in a number of different interesting ways. So in addition to the search box, we also have a browse interface. You can dive right down into each one of these areas, and I'm actually going to jump into demo mode if the demo gods will participate here. And what you can do is jump into a domain. We have a very simple two-level deep subject domain here. And within each one of these domains, without even having to do a keyword query yet, maybe a little bit slow, you will get ranked lists of all of the top authors, the top publications, the top journals, and the top conferences in that domain. And there's a number of different ways that you can start slicing this information. You can look just in the recent years. If you're looking at organizations, you can slice that by geographical region, etc. It does also work as a search interface as well. So if I'm searching something like hydrology, you do get a set of search results, and you can see here at the top where we've actually done a poor job of extracting authors' names out of the document. But if I do search for an author, let's pick somebody on our team like Robert. Here's a case where Robert, I think, has published some publications under Rob, some under Dennis, some under Dennis R. And the challenge here for us is to find the publications under the different variants of his name and to aggregate them together into a single author profile page. So one of the popular features of the site here is and something that Google Scholar has started to copy from us in the past few months, is to create an author profile page that gives a sense of the publication history of Rob, the citation history of Rob's publications, either in a cumulative or in an annual format. And over on the left-hand navigation, a number of different pivots around Rob as an entity here. So you can see a list of his top co-authors, conferences that he's published at, journals that he's published within, and then keywords that have been extracted from the full text of his publications. If I go into a publication record, let me dive into his list of publications and sort these by citation count. Within each publication itself, we also offer a similar profile. So here is a entity page, a profile page for a publication that will show how this publication has been cited over time, as well as extracting from the citing publications some citation context. So this particular article cited Rob's article here, and this was the sort of bounding text within the full text of that document that the author of the citing document is referring to. And if you scroll down the page, you'll also see things like the references that were included within this article, and these are things that we've pulled out of the PDF itself, and then links to the citing articles themselves. And we do the same thing for a few other entities in the system as well. So here I'll pivot onto the journal page, and you get the same idea. This is a page that aggregates together all of the information about the journal, Geophysical Research Letters, the top authors within that journal, etc. Okay, so that's the general idea of Microsoft Academic Search. Come back into the deck here just to round out a couple of other the entities in our system. We provide that same sort of information around keywords. where we have extracted a keyword or a key phrase out of the literature and try and marry together occurrences of that phrase in either the initialism. In this case, sometimes it shows up as GCSF, and sometimes it shows up as, I'm not going to try and pronounce it, the long version of this. And we'll pull definitions then out of the literature. So if you're actually doing research in a particular area, you can get a sense of how that particular phrase. So you can do research here for things like SARS, and you can see definitely when SARS literature peaked in about 2005 and how that's tapered off over time. And then lastly, on the talk about the journal pages, we provide an organizational roll-up as well. So we'll aggregate together all of the author's institutional affiliations and provide a timeline view of an organization, and then as well be able to do things. You can see up in the upper corner here we have this comparison button that allows you to put in any two organizations. Yikes. I made my presentation unhappy. So if I jump into, live demo gone bad here. There we go. So if you click on that organizational comparison button, you can enter in a second organization and pick the domain that you want to compare here, either at the top level domain or at the sub-level domain. And what you'll get is a comparison of the publications of those two institutions over time. Tag clouds here that show these, in this case, are the extracted keywords from the literature that are more unique to MIT in this case, the ones that are more unique to Stanford in this case, and then the areas of that Venn diagram where they overlap. And then down below, you'll get a list of the top authors within that domain. So it's another way of sort of sorting through and comparing institutions within a certain domain area. We provide a number of other visualization features. If you go to the home page, you'll see a little left caret and right caret that allows you to pivot between the domain-based browse view of the site and a number of our visualization tools. But I can show you here that we provide a number of visualizations for things like citation path, co-author graph, a genealogy graph that shows a relationship between researchers and their advisors. If this displayed. All right. So that is the site. That's the sort of end-user portion of the site. But because this is an ongoing research area for us in ways that we can do this entity extraction, do a certain level of deduplication of author records, of research article records, but also merging these things back together and aggregating them at the proper level, we've opened this up. We're crowdsourcing the actual editing of the site as well. So we allow anybody to come in and to make edits to the records. You can edit the author metadata. You can do things like adding profile pictures and adding institutional affiliations. You can change the data in there if we've gotten that wrong. You can merge authors together if there's multiple forms of the same author. And you can add new content into the site either by uploading a BibTeX file or by providing us links to PDF records. And this is something, as I mentioned at the beginning, that we're constantly growing right now. We're only at about 40 million publications, and we expect to double that over the next 6 to 8 months as we consume more information that we're acquiring from the publishers. There's a number of ways that you can get data out of the site as well. So we provide a couple of widgets that you can take. These are the Silverlight controls that show the co-author graph and the co-author path visualizations. And if you navigate to those pages, you'll see a little embed link on that site that allows you to grab a little bit of JavaScript and put it into your own site that will then make a runtime call back to our database and display that Silverlight control on your own page, as well as things like publication lists. In addition to that, every one of the entities, as well as the queries, is accessible via an RSS view as well. So you can go in and subscribe at the journal level or subscribe at the author level, and via RSS feeds, you'll then get any updates for new publications or updated publications that have come in for that particular entity, the author or the publication or the journal. But if you want to go deeper and you really want to interact with the data that we have in the system, we do have a public API. It is limited to non-commercial academic purposes only, but if you want to get an app ID key, you can go to the site and there's a link. That's not a URL that you're probably going to write down right now, but at the bottom of the page there's a help link, and click through that and there's a how do I request an application ID. We'll send you an application ID, and there's lots of great things that you can do with the data. Just to give you a very simple example here, I have improper use of Excel here. This is my Excel spreadsheet as string concatenator. And what you can do here is you can request any of the entities that I mentioned out of the system. So if I want to do things like I want to get authors out of the system, and I want to get authors from, let's say, Microsoft. Oops. And I want query term to be databases. So authors who've written things that have something to do with databases. And we return data in a number of different ways. The easiest thing to work with is the JSON service that will return JSON records. We also have a SOAP interface that will return XML. But I'm going to cheat and use something just for demo purposes, which is piping that JSON data into an HTML table. And just grab that URL that stuck my application ID into it, stick it into my browser, and one of the limitations on the API right now is that we only allow you to request 100 records back at a call, and you can only make 200 calls into the system per minute. And we try to throttle that just because we don't have this running on a huge number of servers at the moment, as you can tell by the performance. But what this will now do is it will fetch 100 rows of author data out of the system and give you a next identifier if you want to fetch the next records from us. You will also get the author IDs if you want to then turn around and make a secondary call and get information from the author. That will then give you all that author's publications as well as ways of pulling citing publications from them. And with my final demo gone horribly wrong, the last thing I wanted to mention was my information, our Twitter hashtag. Follow us on Twitter, or feel free to subscribe to our Facebook page. It's called Scholarly Communication at Microsoft if you want to keep up to date on new releases of academic search and new ways of interacting with the underlying data. Any questions? Say that again? We allow searching on DOIs in the UI. One of the things that I want to add right now, so we have a very minimal advanced search here. So you have to put in a DOI colon and then the DOI that you're looking for. We don't allow right now wildcarded DOI searches. We just haven't implemented that yet. You can't do a prefix if you want to get everything back for a journal. And we don't yet support querying by DOIs in the API. So we just need to add that. Anything else? Yeah? I'm sorry, can you say that again? What's a paper and what's not a paper? Yeah. So it's a good question. The short answer is we don't. We want to be, from a philosophical point of view, we want this to be as inclusive as possible. We are focusing on our efforts right now in getting in the journal literature. And because we also then are doing this entity extraction around the citations within the literature, we have this sort of secondary effect where we end up having a lot of books, and in some cases web pages, in our index because that article that we've indexed is citing a book or a chapter in a book. And so we will have other artifacts. We're not yet focusing on going after the monographic literature. We may attack that in the future. There's a few other areas that we'd like to explore, like bringing data sets in, bringing software as entities into the system. So we're not going to prevent things from coming in, and we are going to focus on getting comprehensive in a few other areas as we queue those up.
Okay, so in keeping with exactly what Alex said there at the end about hooking up data to these publications, I'm going to talk a little bit about the data curation for Excel that Lee mentioned on the first day in brief. And then I am going to go on and talk a little bit more about what's on the agenda, which is the Microsoft Translator Hub. First of all, before I get into this space, what this tool is targeted at is the long tail of science. So for those of you who've read the fourth paradigm, you'll know that these are folks that are still using just the desktop to do most of their compute power and also gathering data and typically saving it within Excel. This project could not be possible without partnership. We're actually currently working with the Merit repository at the University of California Curation Center. We're also working in conjunction with Gordon and Betty Moore, who's co-funding this project with us. And Data One is also one of our partners, where we're trying to be compliant with them and the repositories that are under the Data One umbrella. So what the vision of it is to aid scientific discovery by ensuring that data management and repository compliance is done for the data that's been captured inside of Excel, which is a lot of data right now, particularly in the environmental scientists. And that's actually our original focus for it. We're going to focus, starting with the E3 area, where people are doing things on climate change, on environmental science, oceanography, and atmospheric data. We are partnering with Data One. We want to be a part of the solution. While we ourselves are not in the business of doing storage, search, and curation and collaboration, they are. What we want to do is facilitate them to achieve their objectives that have been set out by the National Science Foundation. We want to be able to make it very easy for people who are maybe a little bit less comfortable with interacting with repositories to upload them very easily from within Excel, or to do a drag and drop if they want to use our web service. We do have an add-in solution that we're going to be providing in addition to providing a web service. Both of these applications that we're developing that are fitting under the data curation for Excel are going to be made available open source as Apache 2.0. We're thinking about not only putting that in OuterCurve, but also in the Apache open source repository, so people can take these technologies and build on them. As I said before, we're going to start with E3 data. But one of the objectives of this, and we just added a milestone to the project to do, was to allow this particular application to be very extensible. So while today it's compliant with Data One, that means in the future it could be compliant with some of the other types of repository activities that are happening, and particularly in Europe right now. So the whole way along since the beginning of this project has been to engage with the community. And we've literally been collecting requirements for nearly a year now. And as was mentioned on the first day, all the documentation has been collected by a person who's our community program manager. And there's a lot of links here if you want to actually go out and take a look at the data that she's been collecting. And what we've done is we've boiled that down into a very developable requirement spec that's currently underway. We are just in the early phases of development. We have a 4 milestones development cycle that's going on right now, and we're just in our first milestone. But what I want you to take away from this really is that we're not building this in a vacuum. We very much engage with the community, and we are building what they've specifically been asking us to build. Once we have a beta solution, that will happen between our 3rd and 4th milestones. We're going to put this back out into the community, let them use it, tell us where they think improvements need to happen, and then we'll have a final milestone to address any of the changes that they may have recommended. We are looking for additional partners, particularly for people who want to pick up the code or work in conjunction with this to deploy it on other types of repositories. And our planned ship date is this summer, so it's a very aggressive schedule. Our planned scenarios really are, the first one that we got hit with was, I'm out in the field, I'm sitting by the campfire, I collect my data, but the minute I get back, I want to be able to upload stuff to the repository, get a unique document identifier. So we want to be able to have that happen and have it happen seamlessly for them, that they can actually get this unique document identifier that they can later use for citation in publications. So for instance, if they were to publish something in PLOS, you would be able to see the particular paper that they've written, but then also be able to access it directly from, access the data in the repository from the unique document identifier. They can upload the new data at any time. So for instance, if the data changes, they can add to this without changing their DOI. And then we want to make sure that whatever data goes up there is repository compliant. And this refers to both the data that's in the document itself, within this Excel spreadsheet or in the comma separated value document itself. And also we want to make sure that it's repository compliant with regards to metadata. This is how we enable the search and collaboration to take place, is by speaking, handshaking with the repository, finding out what the appropriate metadata is, bringing that into Excel and prompting the user to fill in that information. We also extract any document or file properties and immediately populate that into the metadata. If repositories cannot take a native Excel document, we check to make sure that it is comma separated value compliant and suggest any corrections before they upload it, so that they don't upload it and then they lose their charts, they lose their tables, they lose all kinds of information. We actually allow them to convert tables to text and things like that. Our stretch goal is that in that fourth milestone, if we've done our job right, gathering all the requirements, we may have some time to actually implement some of the extensibility to other types of repositories. So now for something really, truly, completely different. I'm trying to stay on track. So as Evelyn foreshadowed, I'm going to talk a little bit about natural language processing as well. This is where my background is. I'm actually a machine learning person. I've done a lot of work in NLP. And one of the things that should be of interest to this group, and also you got to see a little bit of a demo earlier from Arjumand, is being able to translate between two languages. So that mobile application he was showing, well, it was built on top of Microsoft Translator. What we're doing is taking that a step further. So the way in which we've developed translation systems in the past have predominantly been very customized. So we gather a bunch of data, we tune it, we train it, and then we ship a language out on Bing. But that isn't something that's a very extensible model. That isn't something that can scale up to a large number of users. So the purpose of the hub was to actually create a platform whereby anybody could create a translation system between any two languages. So one of the things that enables, it allows you to take advantage of some of the linguistic properties that are similar between languages and build your own custom translators. But really, when you think about some of the scientific communication barriers that exist, it's to try and address as well. So scientific publishing is starting to take place more and more in a variety of different languages, and that creates a communication barrier for your students. Human translation is slow, it's not specialized, and it's extremely expensive. So being able to automate that process would be valuable. And each domain has its own lingua franca. So even though a word might mean one thing, I remember when I was working as a research fellow at the National Library of Medicine, one of the computational linguists there said, if only the chemists would speak the same language as the doctors. Well, that's just never going to happen, is what I told him. I said, you can just forget about it. So it's ways to be able to map over the top of those or create very targeted domain-specific models would be very valuable. And there's a high amount of ambiguity even within domains. And so if you're using a general purpose automated system like Bing Translator, it's probably not going to do very well on very highly technical text. So what we wanted to do is create a solution that would bridge the gap between translating online materials through automatic translation. We wanted to create a system that would take very targeted, very specific inputs and create a custom system that you could access through our standard APIs. And so those are HTTP, AJAX, SOAP, and OData. So literally you can tap into our APIs, create a very customized system, and then be able to translate that. So for instance, a use case for this would be able to translate online course materials from books that have already been translated that are in a particular domain, such as chemistry or oceanography. You can actually create a custom system, and that creates a private model. So now you're not accessing actually Bing. What you're accessing is a private model that's your own custom model, and yet your website can be translated automatically using this very specific domain model. And it's privately accessible. So what I thought I would do is, this is the system, and I was hoping to have time, and I do. I have a little bit of time to give you a live demonstration. So I'll go ahead and go into the system. Ooh. Well, it would help if I could type. So I have a lot of projects that I've got running right now, several of them. Some of these actually haven't shipped. Hmong is actually our most recent language. This was a completely community-developed language, so Microsoft didn't have to go out and custom tune it. We gave them the hub. They were our alpha testers. They uploaded their data. They created their own system. What I'd like to do right now is to show you how you could create a project on your own. So let's just call this called oceanography. And 2 languages, just throw them out at me. Italian, okay. Oops. Another language? Hmong, okay. Can do that. But I think what's really interesting here is I can go ahead and select it, but I don't know if you've seen what's available in Microsoft Translator today, but it's actually 38 languages now that we've added Hmong. This list is considerably longer. There are over 1,200 languages that we presently support. Now, there are more than 7,000 languages in the world, but many of those are not actually written languages. So we only support a few of the click languages. In fact, this very first one, I mean, I don't know how to pronounce that, but that's an actual click language that's spoken in Africa. But I can also just type in Italian here and get it right away because I'm lazy and I don't want to search through that system. And then even different dialects. So we have green and we have white. But white is the one that we're shipping today. That's Hmong Da. Here's the trick. Here's the thing I really wanted to show you. So if you want to scope this to something like chemicals or to something like science, you can do that. And then further classify it down here. Oops. So I can go ahead and now create a project. And this is my own private project. I'm given an application ID that allows me to access it. I just go ahead and I can manage my members here. This is where I go out and invite community members to help me improve the system, review the system, upload new data. We have 2 different types of relationships, so we oftentimes meet with people who want to create that custom model, but then they have worker bees who want to actually manage the project, so we have co-owners. And then we have reviewers. These are people who you trust to review, and then there's also communities, which are in a kind of an untrusted relationship, but they're allowed to submit as many translations or corrections to the system as possible. Okay, so I'm going to go ahead and stop there because I'm out of time, but if you guys have any questions for me, I'll take those now. Two talks in one. Extra value. Yes? Oh, so actually, it's interesting that you mentioned that. It's because it's a controlled language. It's actually possible to do it. What we've been working with our Microsoft Research Asia team to do is to try and translate pseudocode in and out of SQL. Sure. Right. Yes. You as a project owner can narrow it down. So that's actually for you. So that means you'll know to upload data that's in that specific domain. So I think the answer, it is metadata, right? It is metadata right now. However, we are working on domain-specific models within languages, which would enable the feature you're talking about. Uh-huh.
Okay, sure. I'm Jie Liu. I'm a researcher in the Sensing and Energy Research Group at MSR. I'm going to talk about a project that's less of a product. It's more like a research project in collaboration with MSR Connections team, and in particular Yan Xu and Dan Fei's team. A bunch of people also worked on this project. We have our collaborators, Ada Ramos, who's actually sitting over there, and Qiang Wang from China is helping us building some hardware platform. So the goal of this particular project is really try to cut we'll call it cutting the long tails of environmental observations, meaning we want to move beyond the typical infrastructured way of monitoring and do environmental sensing. You can see a couple of examples here. Some of them we did together with scientists in Swiss, and some collaborating with people in Brazil, putting these very high towers and environmental sensing equipments into the forest. And this is a project that people at Berkeley have done to actually climb up to these redwood trees and put sensors on those trees to monitor the humidity distribution. These are what I would like to call infrastructure environmental sensing. These are, you actually plan it, you did provisioning and carefully install the sensors, carefully and try to understand what variables you want to sense, and carefully manage the data that come out of these. In the last several years, in particular with the proliferation of embedded devices and personal consumer devices, another paradigm sort of emerged as what people call the participatory sensing, where you have a goal, right? You want to derive some collaborative behavior or information out of sensors, but you don't really have a way of provisioning, right? For example, let's say we want to build the traffic out of users' mobile phones' GPS data. You don't really have control to say this person should go on that street and so on, but instead, you rely on crowdsourcing, a lot of people having your applications driving on the road to provide you data, and you merge them, you take advantage of the coverage and the opportunities, the so-called opportunistic sensing, and you merge the data to create what you want. And a lot of projects or systems has been built around this concept. For example, Bing has a photosynthesis application that you can take pictures from different different people and different locations, figure out where these pictures come from, and actually stick together and to give you a view of a parametric view of the either the indoor or the outdoor environments. People have done this for the signal strengths for mobile phones, for noise level sensing, and so on. So they really become a new way of collecting data. With this in mind, right, we look at what people do in the first generation of mobile sensing. What kind of devices people do in either sensing wildlife animals or the participatory sensing for environmental sensing and other places. We see these rather bulky, self-contained, and usually not very efficient devices. This is early work done at Princeton, so-called the ZebraNet. They actually put a big color on zebra, try to track their locations. That's a device that Intel built to do environmental sensing. Actually, it's basically a cell phone that you clip on your backpack and you carry them around. Of course, you can use your phones and the sensors on the phones to do a bunch of sensing work. But usually those are not enough for environmental science applications. You want to extend them. And that's exactly what we're trying to do. We're trying to extend this to the next tier of embedded devices with the sensors that serve as the accessory of these mobile phones and then rely on the powerful cloud and the accessibility of the platform to get these data available to the end customers and users. And in particular, this project is looking at the sensing platform. It's a sensing platform that's portable, provide useful information, and can be easily connected to mobile phones. And this is the project CLEO. In particular, we'll start with actually building a hardware platform that has several interesting properties on it. One of them is, well, if you think about a sensor platform that will eventually provide you data, you really care about two most important things are time and location, right? You want to know where this particular data point is collected. And for that, we look at a couple of interesting ways of getting those information. And in particular, we take advantage of the so-called WWVB. This is a radio protocol that actually a single station covers the entire United States, and there are other similar systems available in different countries that broadcast an atomic clock signal, and you can receive it using very low power to synchronize your device clock. There are watches and wall clocks that build this way, and we incorporate that into this device. The other is our own research results that Ada actually spent a lot of time work on called LEAP, which is low energy assistant positioning. It's a way of offloading GPS processing to the cloud rather than do it on the device. And as a result, we can actually save orders of magnitude energy consumption on the GPS sensing side. And the third one is the communication to the phone. This we borrow idea from our colleagues at University of Michigan. It's actually an old idea to use audio ports, use modem-like communication to the phone, so you don't have to rely on the particular model of the phone and particular connectors or wireless protocols, because the audio port is pretty much consistent and uniform across all mobile devices. And from there, once the data get into the mobile platform, we can upload it to the cloud. We support OData for the data management and accessibility in the cloud, and WWT as the way of visualizing and mash up different kinds of data. So just to go a little bit detail into the technologies, WWVB, in the United States, there are these towers or antennas in Colorado. They use long wave radio to broadcast these signals. And we obtain these receivers that actually consumes like sub-milliamp power consumption to receive these signals. And in fact, you only need to receive maybe a couple of these signals a day. That's enough to synchronize the cloud to provide good enough information for the location sensing, because GPS also needs clock. Another interesting technology is the low-energy GPS technology. Instead of doing the GPS sensing on the device, which takes a lot of signal processing and CPU cycles, the device just buffers the raw data. And we have a way of using only 2 milliseconds of raw GPS data together with a timestamp that's collected by the WWVB radio, and put that together with the actual sensor data and send that to the cloud. We're actually archive it on the device and upload it to the cloud later on at night when you have connectivity and power. And then the cloud uses software-defined GPS technology to actually extract the information, everything you need from that 2 milliseconds of raw data. In comparison, in terms of energy efficiency, compared to typical mobile phone-based, just black box GPS sensors on the phone, we're like 3 orders of magnitude more efficient. So we're talking about, just to give you a sense of analogy, with a pair of AA battery, we can run this GPS, this way of sampling GPS, for 1 sample a minute, and the device can last for 3 years. That's the kind of energy efficiency we're shooting at. But in comparison, if you turn on your GPS on your phone, the phone dies probably in 6 hours. Audio jack communication, again, this is technology-wise, it's not that surprising, but it's a clever way of adapting to all different kind of phones, so you can get the data into the phone. The way it works is pretty much like your old age modem over telephone wire. Put that all together, we've built a hardware platform that has a solar panel that do energy scavenging and has a thin film battery. It doesn't. It holds a 0.7 milliamp hour of. This is probably 1 of 2,000ths of what your phone battery will hold. Right? It's a very thin, 0.2 millimeter thick thin film battery. That's charged by the solar panel, and then we have the GPS and the clock synchronization radio. For this prototype, we have light and temperature and humidity sensor on it, but it's extensible. You can add more sensors to it. We really put this into the mode is to put it into a open source design. So when we're ready, we're going to release the design. You can take it. You can build your own sensor platform. You can add your own sensors, and we provide the firmware and the hardware, so you can communicate and upload the data to the phone. And we have web services under construction that will take these raw GPS signals and convert it and turn them into latitude or longitude locations. If everything goes well, hopefully we're going to release this in the fall of this year, hopefully by the faculty summit time when if you're interested in coming. And from there, hopefully we can build a community of people using these technologies to do environmental science. Okay.
Is there audio? Okay, well. Thank you for patience during setup here. So right now I'm playing a tour I created where we're bringing in orbital elements for the International Space Station, putting a 3D model here with the that's actually following the orbit of the International Space Station along with a shuttle here, and then we're animating the shuttle doing a decoupling from the ISS. It's sort of a little bit of a fantasy because it would never spin that close to the ISS in real life. So Alberto, you don't have to correct the thing, but we're trying to tell a story here, not necessarily show exactly real-time data. At any rate, but this environment here, let's go ahead and I'm going to go ahead and pop in and find a specific spot on the tour here, and I'll go ahead and close the tour, keep the layers intact, and I'm going to run a Kinect control for worldwide telescope, and this right here, we started demoing this publicly at Mix last year, but as we've gotten the new pardon me here, as I need to track down the correct
Wish we could have had a break beforehand, because this takes a little bit to set up all the hardware and get all the software running. Okay, here we go. So let's make sure. I'm going to make sure that it frames me and recognizes me. It needs to be tilted down a bit. Okay, perfect. Oh, great. Okay, here we go now. So now we can actually come here and fly around the space station here. And basically, I'm just using gestures here, like if I'm on a multi-touch wall. So I can zoom in, I can zoom out. And right here, one of the things is if I just sit here, and we have time going. Let me go ahead and, oh, why bother going back to my computer to change time? Time slow. Time slow. Time fast? Well, but we have, if the voice commands are implemented, let's see, move up. Well, I'm not sure why the voice is not working right now, but so we can come in here. Let's go visit the shuttle itself. Move back a little bit and bring that in here. And in this orbit that we're tracking, if we speed time up, we'd actually be watching from the view of the ISS orbit, which is kind of a new function we have. Now we're kind of zooming back out. Solar system overview. Okay. Oh, there we go. Did recognize me. So now we're going to take an overview here and look across the solar system. So we have our planets. We have the asteroid belt here. We have all our trans-Neptunian objects and orbits go all the way out here to beyond our own solar system into the rest of the stars. See right there? That's Orion, constellation Orion. But as we zoom back out, see how it is in 3D? And so we're now out to see the overview of the galaxy, and can zoom out even further and take an overview over the entire Sloan Digital Sky Survey. And so we can come over here and look, and each of these is an individual galaxy. And we'll look at the Coma cluster right there in the center. So let's go back to go to Saturn. Go to Saturn. I've got to be careful that it doesn't, when you give it dialogue, you can't go and and you can't like just throw it in right after the end of another sentence as a run-on and continue to talk like that, go to Saturn. It's just not going to pick that up. You need to have it as a command that's punctuated by a little bit of white space so that it knows that it's not just words in the context of a sentence. Turn orbits on. Or sorry, orbits on. Orbits, oh, there we go. So, time fast. Time really fast. Time really, really fast. Time super fast. Okay. Time really fast. I guess it's just a little hit. Oh, there it is. It's actually moving. Yeah, there you go. Yeah, some of the inner moons. Time really, really fast. Well, sorry, it's a little hit and miss on this. It might be because of the echo of my microphone. Here we go. Okay, well. Orbit's off. You know, they say never give a speech demo. And I can understand why, because it works, perfectly when I'm in a in an office environment, but then so somehow it always, I don't know if it's the speaker and that you have all this echo, so it's hearing, the internal. Milky Way overview. Go to Jupiter. Here we go. Solar system mode. Earth mode. There we go. So, it lost me. Okay, well, why we're not publicly releasing quite yet for everyone places. We tested in different environments and stuff like that. But this was enabled to a relatively small amount of work with Windows. The Windows SDK for Kinect, which was just publicly released as the final version at the end of February or beginning of February, allows you to basically bring in the Kinect camera and the microphone array and the other resources and things like that, and fairly easily create an application to get the depth buffer, do skeletal tracking, and be able to process the microphone array, connect it up to speech and everything, and truly, I mean, this generally is not anywhere near this. I'm not sure exactly environmentally. I didn't get to, come in and set this up ahead of time, so I'm not sure what sort of environmental issues might be interfering. But generally, it's pretty reliable. In my office, it's like about 98% recognition rate when I'm not in the middle of a sentence and I say a phrase or whatever. It's the microphone array is pretty good. The recognition, skeletal tracking. I'll give you a quick demo here of some of the applications that are available in the SDK samples. So we can bring in like a skeletal viewer here and go ahead and. Okay, hold on one second. Let's. Kill my kill the preview client and run this. And this is going to show you an example of what you can get for it. So we have the color camera view, we have a depth view. Right here's our depth view, our color camera view, and then when it recognizes a skeleton, you have your skeleton. So you deal with the individual points that it's recognizing from the depth, and it's mapping a 3D skeleton with my arms. So if you dance or something like that, it's actually capturing the frames, and it's giving you an array of 3D positions for all of the components of your hand. So it can track you waving your hand like this, It can track your hands. It can track gestures, so you can do like a menu command or other things like that. And I use this to go ahead and pretend there's like a 3D touch screen in front of me, and then I connect. And as I touch the points, I'm essentially doing like the typical pinch gestures for rotation, and then you touch, and it allows me to move like that. And this is really easy to get going with if you know any C# programs, programming skills. You can just install it, or C# or C++, plug it in and go. And the equipment that used to be required to make this work was phenomenally expensive. So it's now for a couple $100, you've got something that you can do an awful lot of really cool stuff with. And at every level, from the full skeletal tracking all the way down to just getting raw buffers off of it. Any questions?